Welcome to the Food Junkies Podcast. Here, we aim to provide you with the experience, strength, and hope of professionals actively working on the front lines in the field of food addiction. The purpose of our show is to educate you, the listener, and increase overall awareness about food addiction as a disease with abstinence as the solution. Here, we talk about all things recovery. Most importantly, how to thrive rather than just survive. So stay positive, make a change for yourself, tell others about your change, and hopefully the message will spread.
Hey guys, welcome to the Food Junkies Podcast. Today, Vera and I sat down with Stephan Guyenet. In this episode, he talks to us about his personal journey of how he got into the study of the neuroscience of obesity and eating behavior, how he came to and why he wrote the book, The Hungry Brain. And we talked a bit about obesity and trying to better understand the mechanisms around weight gain, set point, systems within our bodies, the homeostatic and non-homeostatic systems that exist. We talk about some processed food and sugar palatability, and we, cover some other ground that really sets us up for part 2. So please know that next week you will get to hear part 2 of this interview with Clarissa and myself. But for now, sit back and enjoy the foundation that Vera and I set up with some of the science and information from Dr. Guyenet's book.
All right. Welcome to the Food Junkies Podcast. I'm Dr. Vera Tarman, co-host along with Molly Painshaw. Today, we are talking to Dr. Stephan Guyenet. Dr. Guyenet received his doctorate in neuroscience and has developed an expertise in the study of obesity and eating behavior. He is author of the 2017 highly acclaimed book, The Hungry Brain, Outsmarting the Instincts That Make Us OverEat. He has also designed a course-based body weight management program called the Ideal Weight Program. One interesting aspect for us at Food Junkies Podcast is how Dr. Giyenet upholds the belief that it is the calories that matter the most when it comes to obesity and not sugar and carbs specifically. He does, however, insist that it is the addiction to trigger foods such as sugar that leads us to the overeating, the extensive calories, which then lead to obesity. So calories do count, and it is the sugar that is the driver to the overabundance of calories. I hope I've captured that. So welcome, Stephan. And welcome, first of all. Hello.
Thanks for having me.
Okay. So before we get into the stuff that you've written in your book and your ideas, can you tell us, first of all, how you got into the whole study of the neuroscience of obesity and eating behavior? And
sure. I've always been interested in science, and the brain was always a particular interest for me because it is the most complex object in the known universe, and it's one of the great remaining scientific frontiers, and it's also the thing that makes us, more than anything else, who we are. And so I've always been fascinated by the brain. I knew I wanted to study the brain since before college, and I did my thesis work in neuroscience at the University of Washington studying neurodegenerative disease. And during that time, I developed an interest in obesity because it's a condition that affects a lot more people than the condition that I was studying at the time, which was a rare neurodegenerative disorder. And so for my postdoc also at the University of Washington, I switched to studying the neuroscience of obesity. And I quickly realized that the brain is really the central organ if we're trying to understand obesity. And I think some of that is really pretty intuitive. The brain is the organ that generates eating behavior. So what you eat, how much you eat, those behaviors are all generated by the brain. How much physical activity we get. And also the brain is the site of the only known regulatory system for body fatness in the human body, in the hypothalamus. The two things occur to me. First of all, the brain is very important for understanding obesity. And two, this wasn't really widely understood. And so there was all this research that was going on in my field that was not really being widely disseminated to the public in really intelligible form. And so I saw an opportunity to bring that research to the public. And that's what I did with my book, The Hungry Brain. It was published in 2017. And I really feel lucky to have been the person who got to write that book. because I think it was a really important topic and a really important need. And I was just kind of the right person at the right time to write that book.
Yeah, that's right. And one of the first books that really addressed that issue. So we continue on to this day. So one of the things that you say, and just want to clarify. So are you of the mindset that eat less and expend more energy, a model of weight gain, that eat less and burn off more?
So
you represent that?
I would say no, as far as that phrase is commonly used. So what I think is that calories are a very important step in the mechanism of weight gain or weight loss. So in other words, if you manipulate someone's calorie intake experimentally, it's a very powerful lever to cause them to gain or lose weight. And if you look at the amount of calories that people consume of different weights, people who are heavier tend to consume more calories. People who are lighter tend to consume fewer. So it plays a very important causal role in body fatness. But that said, when people usually use that phrase, eat less, move more, that usually refers to a mindset of like calorie intake and expenditure is under voluntary control. It's the result of conscious decisions that we make about our food and our, how much we exercise. And it's not really a biological thing. And that is where I diverge from that concept, because it very much is a biological thing. So even though calorie intake is very important to body fatness, calorie intake is biologically regulated.
Right.
And it's regulated. And we know that, right? I mean, we have a thing called appetite that is part of the biological regulation of calorie intake, and our calorie expenditure is also regulated. So, and we know that this fat regulating system in the brain is a biological, non-conscious system that impacts our calorie intake and calorie expenditure. So I would say, if you think about the development of obesity as a causal chain, so at one end of the chain, you have the fundamental environmental and genetic drivers of obesity. And then at the other end of the chain, you have obesity itself. There's all these links in between, right? Like those drivers are affecting your food intake. They're affecting other things. They're affecting your physiology. They're affecting, the fatty acids going in and out of your fat cells. And then eventually you get to the end of the chain. So there's this whole causal chain. Calorie intake is a very important link in that chain, but it's not the only link and it's not the ultimate driver. So those genetic and environmental drivers are the ultimate driver, and they're just acting via the calorie intake and expenditure. Does that make sense?
Yeah. So, and essentially your book is an exploration into all of that. Now, in the work that you've done, I don't know if this would be the easiest way to get into this, but you break it down into the homeostatic and the non-homeostatic drives. And can you elaborate first on the homeostatic? Because this is really explaining what you've said, that there's an unconscious drive to appetite and to gain weight. And in order to understand that for our listeners, let's start simply. So we've got the homeostatic and then the non-homeostatic. So tell us about the homeostatic. And in that part, you've kind of alluded to this. You talk about the adipose set point and the lipocyte. Lipocyte. I think that's really interesting. If you could tell us about that as well.
Yeah, sure. So I'll start off with a little caveat, and that is that the brain is really complicated and everything's talking to everything in the brain. So, to some extent, these are artificial distinctions that we draw about, that we kind of divide up into conceptual domains. But broadly speaking, the homeostatic regulation is the stuff that is trying to keep our energy status within a certain range. So we have things like hunger and fullness that try to keep our meal size within a certain range. And then we have so that's kind of like the short-term regulation of the body's energy status. And that is mostly regulated, at least the satiety, the fullness is mostly regulated by the brainstem, which is the oldest part of the brain. And then we have the longer term regulation, the regulation of your actual long-term energy stores, which is your fat mass. Fat mass is by far the largest and most plastic, in other words, most modifiable energy source or energy storage site in the body. And so we have systems for regulating that too. And the system is primarily located in a part of the brain called the hypothalamus, which is on the bottom of your brain, right in the middle where your optic nerves cross. Mm-hmm. And it's also a very, very old part of the brain, but not as old as the brainstem. And so basically you have these two systems that are interacting. You have the body fat regulatory system that is measuring the amount of fat you have and trying to keep that within a certain range. And it has many different tools that it uses to try to regulate your fat mass. Probably
what we're talking about there is the set point, right? That there is an actual set point where my weight is typically the same all the time. Is that what you're referring to now?
Yes. So I'll take a little step back and give you an analogy. So there are many regulatory systems that we can observe both in nature and in engineering. One of them that we commonly understand is a thermostat in your house. So with your thermostat, you set it to a certain temperature. If the temperature, and the thermostat's always measuring the temperature of your house, right? It has a thermometer. It's measuring the temperature of your house. If the temperature drops below what you set it to, it will kick on the heat. And if it goes above that temperature, if you have air conditioning, it will kick on the air conditioning. So it has these responses it kicks in to try to maintain the stability of the temperature around the point that you set it at, the set point of temperature on your thermostat. And your body does this with temperature as well, right? I mean, we have this incredible regulatory system for body temperature that maintains your core temperature within about 1 degree Fahrenheit. No matter, you could have, the weather could be differing by 40 or 50 degrees outside, and your core temperature is going to stay almost perfectly constant. And that's because of a kind of similar system where the system is measuring your temperature, both your core temperature and your skin, to detect threats to your core temperature. If your skin is getting cold fast, your brain's like, oh, we got to stop this before it gets to the core. And then by enacting a variety of behavioral and physiological responses to try to maintain temperature stability. So, for example, if your brain detects that your core is getting a little colder or might in the future as a result of you just jumped in a cold lake, it's going to start doing things like contracting your small blood vessels in your skin, your capillaries. That's a physiological response. You might start shivering, might activate your brown fat to generate more heat. And then it will activate behavioral things like making you want to get out and put your clothes back on and dry off. And
so with food, that's appetite?
Yeah. So
the food bit.
So similarly, if we bring that analogy back to body fat regulation, you have a certain range of body fat that your brain is prepared to tolerate or prepared to accept, I would say. And if you go outside of that, especially on the low end, if you try to lose fat particularly, it will start to activate behavioral and physiological responses to bring you back into that range. One of those is hunger. It will also commonly trigger cravings and increased attention toward calorie-dense foods. And it will curtail your metabolic rate. So it will slow your metabolic rate a little bit. But mostly your brain tries to bring the calories back by increasing your food intake. That's the main lever that your brain uses when you lose weight, to try to get that extra energy back into your fat stores.
So I don't want to get into the whole concept of fasting yet, because that's a topic maybe we can get to later. But wouldn't that mean that if you're trying to fast, it is going to make you want to look towards the more sugary or calorie dense items because you're starving?
Yeah, that's an interesting question. I know that during a fast, many people actually report that they don't have much appetite. So I think that situation may be a little bit different. I don't actually know a lot about that, but I think there may be kind of special adaptations happening there while you're in the fast. But I think once you come out of the fast and you start eating foods again, that's when your body's going to say, whoa, we're depleted. Yeah. Let's crank up the appetite.
Which is what happens if people end up binging unless they're careful. But okay, so there's this set point where we, like shivering or sweating, we self-regulate our weight. So what happens then when people actually gain weight or permanently lose weight? It's like, if we have a body set point, why is it that we can actually change that?
Yeah, this is a critical question. So I will say, again, with an analogy to other types of set points in the body, there are other types of set points that can change either temporarily or permanently. So a fever is an example. When you have a fever, your body's temperature set point is temporarily increased. when you have hypertension, high blood pressure, your blood pressure set point is durably increased. So yeah, essentially your set point is increased. So a person with obesity, their brain on some non-conscious level, again, this is not conscious at all. This is just stuff, gears whirring in the background that you can't really access or control. Their non-conscious brain resents weight loss just the same as a lean person's brain resents weight loss. And so you can see this in scientific studies where if a person with obesity loses weight, they are much more likely to regain that weight than a person who started off at that same lower weight but hadn't first lost it. Does that make sense?
Yeah, certainly. It certainly makes clinical sense.
Yeah. And basically, they will keep regaining the weight until they get back to their former weight, and then they'll kind of more or less stabilize. So obviously the set point can change because most people gain fat over the course of their lives. So obviously that is increasing over the course of their lives. Interestingly, if you experimentally overfeed people, most people will actually resist weight gain in the short term. So if you just feed them a lot of food, most people will actually physiologically and appetite wise will resist that fat gain, and they will lose most of it as soon as you stop overfeeding them. So there is some resistance in the upward direction as well, but it seems a lot less robust than the resistance to weight loss.
Well, you said short term. Is there a long term? Because we do see people who go to 300, 400, 500 pounds. So something's happening there.
Exactly. Yeah. So I'm trying to draw a distinction between the kind of gradual weight gain that people experience over the course of many years versus an experimental setting where they might overfeed people for a few weeks or a few months by like 50% of extra calories, which is much more than a person would typically consume, like a person with obesity, for example, much more than they would typically consume. So I'm trying to illustrate that there is some kind of mechanism, at least in some people, that limits weight gain. But obviously, whatever that is failing to stop the gradual weight gain that most people experience. And by the way, I say gradual. I don't want to, give the impression that in everybody, this is like a, small incremental day by day gain. It can fluctuate up and down a lot over time, and there can be periods of gain and periods of plateau or loss. So I don't want to give the impression that it's just a very, gradual, constant thing. But we are talking about, a process that usually plays out over a period of years.
Okay. So now that we're not talking experimentally, we're talking long-term gradual process. Why is it that somebody can go to 300 and 400 pounds? Like what's happening to that adipose set point or lipostat? Is it starting to fail? Is it starting to malfunction? And what is it that's changing that?
It's a really interesting question. So first of all, the first thing I'll say is that as far as we can currently tell, that lipostat, that mechanism that regulates body fatness, has not failed in people with obesity. It has just changed its set point.
Yes.
So it's like obesity is the new lean as far as those circuits are concerned. And obviously, in most cases, this is not something that the person desired. Again, this is totally non-conscious brain circuitry making these decisions. And again, the reason we know the set point is increased is because people with obesity will resist, their bodies, their brains will resist weight loss attempts. And we see this in many contexts experimentally.
You mentioned somewhere something about an obesity gene or mutation. Do you think there's a role there? Because it doesn't seem that it's everybody, but it's a subset of the population. Do you think that there might be something there?
Oh, yeah, absolutely. Genetics is huge. So genetic differences between individuals explain about 75% of differences in body fatness between individuals in modern affluent populations like the United States. So basically, the way to think about this is that almost all of us are swimming in this fattening environment, and the people who have genetics that causes them to be susceptible to weight gain in that environment develop obesity. And people who do not have those genetics do not develop obesity. And most people are susceptible. And
their set point may be more robust than somebody else's who's predisposed to not being so robust.
Yeah, that's right. That may well be the case. That part of the reason is that some people just are better at defending against gain than others, but we're not really sure. I mean, and there could be, you could conceive of many different reasons why in theory that could be the case. But I will say that if you look at the genetics, they've already learned a lot about what the genes are that determine why some people are susceptible and some people are not. And we have a lot to learn about it, but it mostly revolves around the brain. So if you look at where those genes are expressed and what they're doing, typically they're expressed in the brain and they are impacting brain development and brain function.
Okay, so that's the homeostatic. So let's look at the non-homeostatic, because that's the reward piece and talking about dopamine. So if you can tell us a little bit about that, because that's likely where we're coming from.
Yeah. So the conceptual division we're making here, homeostatic regulation is all about the brain trying to manage your body's energy status. So your brain feels hungry because it perceives that you need energy, whereas non-homeostatic is everything else. It's stuff that's not related to energy. So maybe the food is just right in front of you. Maybe it's time to eat because it's noon. Maybe you're drinking a beer because you want the enjoyment of it. Or maybe you're doing it because it's a dopamine-fueled motivational state. And so I think that's the one that you're most interested in. So I'll focus on that.
For sure,
yeah. So, I mean, we have this incredible system in our brains that revolves around this connection between dopamine secreting neurons and part of the brain called the striatum. And of course, there's many other parts of the brain that are kind of involved in this process, but that's really the part of the brain that is regulating our motivation and especially our kind of visceral motivational drive that we might associate with the word craving, for example, or addiction. So every single addictive drug there is impacts this dopamine circuit in the brain. So that's like almost by definition, if something is addictive, it is impacting this dopamine circuit in the brain. And so as it turns out, this dopamine circuit in the brain didn't evolve to make us want drugs. It evolved to make us want natural rewards, things that our ancestors experienced, like food and sex, and probably a bunch of other desirable outcomes as well that would have contributed to the survival and reproduction of our ancestors. So it's kind of like this basic goal setting and motivational system to drive you on a very visceral motivational level toward things that would have benefited your distant ancestors. So this system is hardwired to respond to certain food properties. And this has been worked out in greater detail in recent years. It's really cool to watch this research evolve. So basically what they've figured out is that, and it's probably more complicated than this, but this is the basic outline. We have receptors in our digestive tract, particularly the small intestine. Those detect the chemical composition of the food that you eat. So they figure out what's in that food. They have specific receptors for specific types of things that your brain cares about. Those cells lining your small intestine are directly hooked up to neurons that go up your vagus nerve and straight to your brainstem. And once they're there, they disseminate that signal to the rest of your brain. And that signal is used for things like feelings of satiety. But another thing it's used for is to secrete dopamine. And so the brain is hardwired to secrete dopamine in response to certain nutrients that we eat. So carbohydrate, fat, protein, probably salt, although the evidence is not as strong there, probably glutamate, which is that umami flavor. Again, the evidence is not as strong there, but especially those calorie-containing macronutrients, carbohydrate, fat, and protein. Protein's a little special, so I tend to focus on carbohydrate and fat. And so you eat these things and essentially you get dopamine release in proportion to their concentrations. So when you eat a food that is highly concentrated, particularly when it starts to combine carbohydrate and fat together,
processed food, folks.
Yeah, exactly. You start to get higher levels of dopamine release in the brain. Higher levels of dopamine release cause a heightened motivational state. That's what dopamine does. It causes you to particularly to learn that item that you just consumed, to learn on a very intuitive gut level that item you just consumed is highly valuable. And so the next time you encounter it, the next time you smell the smells of it, you see the sight of it, any kind of sensory cue that predicts the availability of that food, let's say it's pizza or ice cream or a brownie or something, your brain starts secreting dopamine again. It recognizes that, it knows the value of the item, it starts secreting dopamine again, and that energizes it creates a strong motivational state to...
And just to interrupt for a sec, for people listening, this is the essence of the beginning of addiction. You've got the cues, you've got the triggers, which basically motivate and stimulate. It's not even that you like it. It's just that you made the connection to now you want this more.
Yeah, I agree with that. The
beginning of addiction is happening, just the way that you're describing it.
And I think I will say that within the research community, it's controversial to refer to food as addictive. I'm not saying that's wrong. I'm just saying there's ongoing controversy about whether they want to use that term or not. I just wanted to acknowledge that briefly. And yeah, so the point that I wanted to emphasize that you made just now is that really the thing that is important is the motivational state, not necessarily the pleasure of that food. It is the motivational state that drives you to acquire and consume it. That's the thing that is going to impact your behavior. And ultimately, that's the thing that matters the most in that situation. And it's the same with drugs of abuse. Like if you are someone who, let's say you really, really like cigarettes, but you're not motivated to consume them. You might have one occasionally, you might enjoy it, but you're not going to be addicted. You're not addicted to cigarettes. If you have a strong motivational drive, then you're going to have a really hard time not smoking cigarettes frequently.
And even if you've had so many cigarettes that another cigarette will make you feel nauseous, you will still want a cigarette. It's not about the liking. It's about the wanting the next one. That's the dopamine.
Yeah, I agree with that. And the dopamine, it's the motivational state, and it causes learning in the brain that sets your future motivational state and your response to cues that predict the acquisition of that reward, whether it's a food or a drug or whatever it is.
And would it be fair to say, I'm always saying this on a clinical level, but just since we're talking sort of scientific academic, would it be fair to say that power, that motivational circuitry can actually trump or overpower any homeostatic, where you're saying, I'm actually full, I don't need to eat this, but this can overpower it?
Yeah, I think so. I think that it's an opposing force. So there's a certain point at which you may feel so full that it doesn't matter how much you want to eat something, you're, sick. But yes, it can cause people to eat more than they would normally eat. So, and I think everyone understands this intuitively. If you're at the end of a meal, let's say you just finished eating savory foods at the end of the meal, usually you're full, right? If I put another potato in front of you, you're not going to eat more potato. If I put another carrot in front of you, you're not going to eat a carrot. But what if I put a slice of cake or ice cream in front of you?
Right.
You'll probably eat that, right? Most people would. I would. And so your body didn't need that energy. You were already full. Yeah. But as soon as it comes in the right form that the brain really highly values on that non-homeostatic level, on that reward level, then suddenly you're prepared to consume those additional calories. So yeah, I think that's right. The non-homeostatic, there's kind of an interplay between the homeostatic and the non-homeostatic. Yeah. And the non-homeostatic can kind of push you beyond the bounds that the homeostatic systems would normally set.
Can I ask you another question? You mentioned about the receptors in the gut that pick up the carbohydrates and the proteins and the fats. What about the stretch receptors? Because one of the things we talk about in food addiction is volume addiction. Can a person, by virtue of the stretching, also going up to the vagus nerve, getting some level of satiety that's very satisfying, could that explain volume addiction?
This is interesting. I'm actually not familiar with this. I would love to hear more about this volume addiction. I'm not familiar with this.
Ollie, do you want to, you see this all the time?
Yeah. So clinically, we do see this, and we do like to ask many of our guests about it because it is so intriguing. And some of the answers that we've gotten have really centered around this idea of the stretch. And then there's a serotonin, oxytocin release. There's some other backdoor mechanism to eventually the dopamine release as well. And so that was my question, is like, is there some sort of, as far as you know, is there some sort of evolutionary reason or biological reason that we would have that mechanism where, like you said, we eat this meal and then you put one more thing in front of us, and you're saying we wouldn't eat another steak or we wouldn't eat another potato, but I do have clients that would, and yes, they would certainly go for the sweets. Absolutely. But they would go for the other thing. Yeah. And so we are always very curious about what could be going on there.
So let me ask a follow-up question here. So would you say this is independent of hunger? So it's not like they're still hungry.
No,
is that correct?
They're stuffed. And it's that idea of, that's how I'm convinced how bulimia happens. People clear because they're so sick and they still want to eat. So the only way they're going to do that is if they throw it up. So that, again, they can get that feeling of getting full again. Yeah.
Yeah, that's interesting. This is not something I'm familiar with. So I'm afraid I'm not going to be able to provide any deep insights. I will speculate a little bit in case it's interesting. The only thing I'll mention here is that, so these receptors in the gut that communicate information to the brain, they're involved. That signal ultimately is conveying satiety information as well as reward information. So, I mean, the stomach stretch receptors are known to be important in satiety. So I wonder if it could be a similar situation where actually maybe that's part of the reward signal too, just like the nutrient sensing.
Yeah. And to go back to, you were saying something. So going now, the other receptors, you said, I was interested that you said there was a carb and there was a protein and a fat, and they seem to be different receptors. I think that's what you said. So could there be a genetic predisposition that some people, that's why a keto plan would work for them, because they get more satisfaction for protein, and somebody who's plant-based is saying, that's I need more of the carbs, the potatoes, the whatevers. Do you think that there's something there?
Yeah, it's a good question. I mean, probably. I don't know. But I would say, if I had to guess, I would say yes, that genetic differences are going to explain, at least in part, why some people respond to certain types of diets over others. But I would say that the two diets that you just cited, like the keto and the plant-based, even though they seem diametrically opposed, they actually have some commonalities that are important in this context.
Elaborate, please.
Well, for one, they eliminate a lot of commonly eaten, highly processed foods, typically, which are the most common triggers for cravings and addiction-like behaviors. And often the plant-based diets are lower in fat. And so those diets both involve macronutrient restriction, which also that fat carbohydrate combination is also a major trigger of cravings and addiction-like eating behavior. And so I think in those ways, they do have some commonality.
Okay. So a phrase that you used that I liked was, my neurons make me fat. I guess that's what we're talking about here when we're looking at the reward or the non-homeostatic model. So we're eating more calories because they're just more tasty. So is that a good way to conclude that?
So I think that is one factor. I think there are multiple factors that lead us to overconsume calories. And I think some of them are actually homeostatic. So in my book, I have different chapters that are on different facets of why I think this occurs. But one thing that I think is important to understand on the homeostatic side is that obesity is a self-sustaining state. So once once a person develops obesity and their set point is elevated, their brain at that point is kind of forcing them to continue consuming that higher level of calories, even though consciously they probably don't want to. Those regulatory regions of their brain are kind of pushing them continually to consume enough calories to maintain that fat mass. And so once that state has been reached, it is kind of a self-sustaining state. But I think there are also a lot of other things that aren't homeostatic that push us to eat more calories. And certainly that reward is one of them. And, one way of saying it is that the food is tasty, but I think, if we want to be a little bit more technical and precise about it, as we were saying before, it's not really the taste so much.
Yes, it's the drive.
It's the motivational state that those foods create.
Got it. Yeah.
Yeah.
Okay. Well, tell us about, so a person's they've reached a set point that their obesity, their fat mass, they're trying to maintain that. So you have a food plan or a weight loss or weight plan. How do you break through? What do you do? What do you offer people?
Yeah. So, So I want to start off by saying that program is kind of in a transition point right now. And I'm not sure where it's going to be like a year from now as a result of some changes that are going on within that organization. However, my kind of thinking along these lines is there are a few different approaches that I take. So the main approaches that I take in terms of trying to help people manage strong cravings or addiction like eating behavior or whatever you want to call that kind of state are, first of all, to limit the cues. So, whatever your trigger foods are, be very careful about not exposing yourself to those foods. Don't have them in your personal environment. Ideally, don't have them in your house. Don't see them, don't smell them to the extent that you're able. And one of the ways that reward works is it kind of over time extinguishes itself or diminishes, I should say, if you're not exposing yourself continually to that cue.
Right.
And so this is like when people quit cigarette smoking, it's really hard for, like the first week. Second week, it's easier. And then a year from then, they might just be totally grossed out by cigarettes. And so there's this kind of gradual extinction that happens of that motivational state, which can be very rapidly reignited if you reintroduce the reward. So smoke the cigarette or eat the food. So I think avoiding the particularly problematic foods in the long run and just letting that kind of settle out, I think is another helpful strategy. And then in terms of the food you're eating simple, lower calorie density foods that are just not as triggering for those dopaminergic systems.
This is exactly what we say in the food addiction plan is exactly, this is addiction talk. So yeah, we're on the same page with you here.
Great.
In fact, wouldn't it be fair to say, the words that we use is you have to actually be abstinent. You cannot, most of the time it's sugar, that's sugar or fat combos. You have to literally abstain from them, not just modify. I was going to ask you, do you think that it's possible to, if you've recognized that sugar or sugar and fat or whatever is a trigger, that you might be able to have a little bit at some point?
Yeah. I think this really depends on what kind of person you are. So I think, I did a highly scientific Twitter poll on this a little while ago. Of course, I'm joking. It's not scientific, but I was just curious among my followers, like, are you an abstinence person or are you a moderation person? Like, which one works for you? And it was basically 50-50, which kind of surprised me. But that's what it was, at least among my followers. So I tend to, this is a, gross oversimplification, but I tend to think that there's two kinds of people. There's people who do well with moderation and there's people who do better with abstinence. I would think that people who are having more problems along the lines of strong cravings and food addiction and like the dopaminergic type of stuff, I would think that those people would fall more into the abstinence would be more effective category. And then maybe people whose weight management challenges are not as much in that category might do better with moderation. That's what I would guess. But I'm not, I don't work with clients. That's your domain. So you probably know better than I do.
So in the food, I realize that you're not doing the program right now, but if you were, with the information that you have, the theory or the perspective that you have, would you see that something like a Weight Watchers program or would work? Or I think I got the impression that you were favoring the Mediterranean, but like, what is your sort of ideal food plan for an obese person?
Are you thinking just like the average person with obesity, or are you thinking someone specifically who's suffering from food addiction challenges?
I'm kind of interested in both answers.
Okay. First of all, I think that the issues we're talking about with strong cravings and addiction like eating behavior or food addiction or whatever you want to call that, I think to some degree, this is something that affects everyone. I think some people have more of a problem with it and some people have less of a problem with it, but I think it's really a spectrum. It's not like there's this sharp cutoff that some people are addicted to food and other people are totally not at all. That's my way of thinking about it. And so I think, there are some people who would benefit from emphasizing that more than others because that may be more of a challenge for them than others. But I think that type of an approach makes sense in my opinion, for the average person who has obesity, at least some element of that, of what we were talking about limiting cues and, abstinence from particular problem foods and not using the calorie dense, highly stimulating ingredients and foods in your diet to the extent that you can limit that. But then I think there are some other things that are really beneficial for general obesity and also people with obesity who may have food addiction challenges. And I think eating foods that have a higher satiety value per calorie, so in other words, they're more filling per unit calorie, is something that's helpful. And basically, I can get into greater detail if you'd like, but the basic principle is lower calorie density, more unrefined, higher protein foods. So, the more refined it is, the more processed it is, the more calorie dense, like rich, concentrated in carbs and fat, added sugars, added fats, the worse it is. The simpler it is, the more unrefined, the lower in calorie density, like more along the lines of whole grains and leaner meats and things like that, vegetables, fruit, whole fresh fruit. I think those are going to be the things that are more supportive to people. And clearly, those are the things that create a lot more fullness per unit calorie. In other words, you eat a meal of those foods, you can reach the point where you feel satisfied with fewer calories than if you were eating different types of foods. And you don't have to count your calories at all to do that. This is just a natural process that occurs when you're selecting certain types of foods. By the way, that's an example of what I'm talking about, where I think calories are important, but I don't necessarily think we need to be focusing on calories in particular as the thing we're trying to change.
Right. Well, so we can use these triggers for the food addiction angle. And is there a way that we can get that body set point back to normal again? It's gone up and now you're defending your weight. Can we get it back? Is there anything we can do there?
Yeah. So this is the big question and is also really the biggest challenge, because if you look, there are a lot of people who've been trying to do this for a long time. And if you look at diet trials, for example, what you see is that people with obesity will lose a certain amount of weight. And then typically they will reach their lowest weight around 6 months into the diet. They will start to regain. And by 1 year, on average, generally, they have regained most of the weight they lost. And then if you follow them up for another few years, usually they've regained almost all of it. So there are more successful and less successful approaches. And I think certainly you get a lot more value if you have good guidance and strong and consistent support. So one example of that, I'll cite the Virta Health study. Have you seen that one?
No.
This is a program that uses a ketogenic diet for type 2 diabetes, as well as intensive support.
Oh, yeah.
And
don't know that study, but know that approach well.
Okay. Yeah. And they've been able to maintain pretty good weight loss for 2 years now, is the latest follow-up that I've seen. And people are regaining, but they're still lower than where they started. So I think that intensive support is really important. But, I want to be really, really honest here that there is no diet and lifestyle strategy that we currently have that can reliably transform a person with obesity into a person who is lean.
Okay. Now I want to challenge you there, and maybe we can figure out what it is. But in the food addiction world, for the people who stop eating, exactly like you say, the processed foods, probably focusing more on protein, which seems like a better option, we can see people who have lost weight and maintain that weight loss 10 or 20 years later, providing they keep doing that food. The problem is that people slip off. And the only way that they're going to eat that food is if they continue to stay in a community that supports their new eating behavior. But they do sustain that weight loss. Like, it's not like, or they may gain some back, but if they've lost 100, they may gain back 5 or 10, but not 40, 50, 60. So what's happening there then?
Well, what I will say is that in any diet approach, you can find individuals who lose a large amount of weight and keep it off. But when you do scientific studies where you're taking a certain number of people and you're following average trajectories, what you find is that the average person is just not able to sustain that. And not, and don't get me wrong, I'm not saying that it has no benefit. You actually, some of the health benefits you get are massively out of proportion to the weight loss. So like the diabetes prevention program trial, people lost like between 4 and 7% of body weight, depending on what year you look at. And they saw a 58% reduction in the risk of developing type 2 diabetes. And that's not biomarkers. That's actual people developing diabetes reduced by 58%. So you can actually see massive health gains even from modest weight loss. But to address what you're saying is, a lot of it, I think, does come down to compliance. I think most people just can't maintain the high level of compliance for over long periods of time. And I don't think scientifically that we really understand whether that is the only explanation. Is it just that people fall off the diet and that is the only reason for the weight regain? Or is it partly that and partly that these systems kick in and they start fighting back, these homeostatic systems, and people just can't maintain the discipline anymore?
I think it's a little bit of both, because my experience is the people who are super disciplined, and they're only that way because they're in a huge community. Like we have a Facebook group and we've got, coaches, groups, all sorts of stuff to sustain that, which then enables weight sustenance. It does seem that over years, even if they're eating the exact same thing, their weight does seem to creep up. And I've been thinking maybe it's got to do with age or something, but there's something beyond just the discipline, for sure.
Yeah, I think so. But I mean, there's no doubt that the better you can adhere to an effective diet, the better the results you're going to get. Absolutely no doubt about that. And the better the support you get, the better you're going to be able to adhere to that diet. I think those are two conclusions that are very well supported at this point.
Okay, so we're getting close to the end of our time. Do you have anything that in this context of addictive, the dopaminergic pathway that you'd like that we should know about that we didn't catch on?
No, I mean, I think that's everything that's important in this context. Yeah. I can't think of anything else off the top of my head that I really want to add.
I do know that in your writing, you do talk about other factors like sleep and exercise and even medication that can actually change that liposet point to some degree. I don't know by how much, but that those things are important as well.
Yeah, that's a good point. I can expand on that a little bit if you want.
Well, maybe 3 minutes, 2 minutes?
Sure.
Okay.
Yeah, so the homeostatic and the non-homeostatic systems can be impacted by other factors, like you said, like sleep, stress. I think a lot of people recognize that stress can be a trigger for eating behavior, unwanted eating behavior, let's say, and lack of sleep as well. People tend to overconsume calories and succumb more easily to foods that might not be supporting their goals when they don't sleep enough.
Okay. So just in closing, what's next for you? So you've been doing this work here. Is there anything that well, actually, before we get to that, one of the questions we ask is there anything that you've changed over your years of working in this field, new insights or new directions in your thinking about obesity and the reward that you'd like to tell us where you are?
Yeah, I think that the thing that has been really cool over the years has just been seeing how some of this stuff has really gotten fleshed out. So when I first wrote my book, I said, we don't really know. We know that the small intestine is a very important site for reward sensing, but we don't know how the signal gets to the brain. And now, not only do we know what cell types are detecting it in the gut, we know exactly what the path is, neuron to neuron, all the way up to the brain. When I wrote my book, we didn't even know that it was neurons. It could have been
so interesting. Are you writing about that? Because that is really interesting.
I am not writing about it. I do share some papers on Twitter, and I do mention it in my talks now. But yeah, I mean, when I wrote my book, it could have been a hormone. We didn't know how the signal got to the brain, but now we know that it is primarily a neural signal. So that I would say that is one thing that I could cite that has changed.
Okay. So what is next for you then?
Yeah. So I do a variety of things, but one thing I'll mention in this context is I am the founder and director of an organization, Red Pen Reviews, which publishes the most informative, consistent, and unbiased reviews of popular nutrition books available. And so we're going to keep advancing our mission of providing high quality reviews of nutrition books to the public. So definitely check out our site, redpenreviews.org. We're a 501c3 nonprofit dedicated to serving the public. And we have a very unique and effective method for reviewing books, and one that is very easy to, when you land on the page, it's really easy to get a quick impression of how the information value of the books that we review.
Okay, great.
Oh, goodness. Well, this has been so amazing to get to witness and watch. I know I didn't really jump in there a whole lot, but I think I was just taken aback by all the information. And I just really appreciate, you being willing to come and talk to us. And a lot of what you had to say really echoes some of our past guests, like Dr. Ted Naiman with the protein to energy ratio kind of idea that he has about obesity and really trying to like treat it with food plans, and really speaking to that part of it, amongst many other guests. Rob Wolf talking about that being able to eat past that switch point, talking about people doing food eating contests and like eating, getting to the point where they're about to get sick, and then introducing a new kind of food, whether it be like a salty food when they've been eating sweet, or a sweet food if they've been all of those things. So it's just been really nice to have that actual science behind what some of our other guests have really started to educate us on. So I appreciate that. But before you go, we do have a signature question for you. So if you could tell a younger version of yourself something about obesity medicine, what would that be?
Yeah, I think if I could go back, I would really pay more attention to the drug discovery space in obesity, because there are a series of new drugs that are coming out and being developed that are poised to really change the way obesity is treated in medicine. And I'm just now getting up to speed on all this amazing work that's been happening for years and years and years. And I've been kind of pessimistic about that space for a long time. And so these new drugs have completely wiped away my pessimism. And I just wish I had been aware of and involved in that space from much earlier.
Great. Thank you.
Yeah, I feel like that's a cliffhanger. It leaves us open to invite you back for a second interview later this year, if you're open to that at all, because I would really love to know more about that. And I wonder if it starts to get into some of that set point stuff and the motivation piece of it and all of that, which I would definitely love to dive in more now that we kind of have this science foundation, to really start digging into how does that apply to us clinically. And so thank you again.
Yeah, that sounds good. I wrote a couple of articles on that, so I can send you those.
Oh, good. Great.
Yes, thank you. All right.
Well, thank you very much for coming to Food Junkies, and we really enjoyed this time.
Okay, thanks for having me.
Thanks for joining us this week on Food Junkies, Recovery from Food Addiction. Make sure to join our Facebook group, Sugar Free for Life support group, I'm Sweet Enough. You can subscribe to our show in iTunes or Stitchers. That way you'll never miss an episode. While you're at it, if you found value in this show, we'd appreciate a rating on iTunes. Or if you'd simply tell a friend about the show, that would help us out too. Don't forget to pick up your copy of Dr. Tarman's book, Food Junkies, which is available on Amazon. If you have any additional questions, both Molly and Clarissa are food addiction professionals and work one-on-one with clients. You can find their websites and email addresses in the show notes. Be sure to tune in every Friday when our new episodes drop. As Vera loves to say, the power is ours.